In this lecture, we're going to learn about static constants. And this is going to be a byproduct of what we have learned about in the last few lectures. Remember that we have designed a cylinder class in the last chapter, I think. And the way we did things, we were maintaining a variable, a constant variable for modeling the pi variable that we use to compute the volume of a cylinder. Now we have tools to make this design a little better. Because remember, the pi variable isn't really going to be used in many other locations. It should belong to the cylinder class. We can't really make it a regular member variable because each object then is going to have its own copy of pi, and we will be basically wasting memory. But now that we know about static variables, we can bind the pi variable to the class itself by marking it as static. That's what we do here. But we can also make it inline and allow for people to initialize this inside the class itself and avoid having to do this in the CPP file like we have seen in a previous lecture. So this is how static inline constants can really help you do a better design. You don't have to maintain constants on the outside. They can be maintained inside the class itself, and each class object is going to have access to this variable if it needs it. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is static constants. We're going to grab our template files like we always do, and we're going to put them in place. And we are going to open this in Visual Studio Code by dragging and dropping here. This is going to open our project or folder, I should say. And we're going to clean up the main CPP file. Okay, we need the cylinder class to play with. So we're going to create files for that. We're going to create a header file and a .cpp file. We're going to hit the new file button here, and we're going to create a cylinder.h file, and we're going to do that again and create a cylinder.cpp file. I am going to put in the code I have prepared before because I don't want you to see me typing all this. This is nothing you haven't seen before. We have our include guard here. We have the class declaration. Inside we have a public section and a private section. The private section is going to model the base radius and the height. And in the public section, we're going to have a bunch of functions that are going to make this class work. We have a few constructors, we have the getters, we have the setters, and we have a method to compute the volume of our cylinder here. The volume function is really not going to modify the class here or the member variables of the class. So I am going to mark it as const. I am also going to mark our getters as const. Let's do that because they are not modifying our thing. And now that we have this, we can go in our CPP file and put in our implementation. We are just going to include the header file, and we're going to be modifying the signatures of our getters because we have just marked them as const. We should be consistent for that here. And the volume function or member function is not going to modify the member variables, so it's also going to be const. Other than this, I think we really are done here. So let's go back to the header and focus on our constants. The constant is marked as static because we want it to be attached to the class itself. It's not going to be attached to any object. And it is inline because we want this facility to initialize that in the class declaration. We don't want to go in any CPP file and do the initialization there because that's just going to make maintaining this member variable a little harder. We will have to go to different places to really maintain it, and that's bad design. So we are marking that as inline. Note that this syntax is only going to work if you are using C++ 17 or a newer version of C++. So we are using C++ 20 in this course, so this is going to work without a problem. And another thing I want you to notice is that we have another static variable on top here. It's going to be modeling the default color for our cylinder here. So this is something you can do. And I am doing this just to show you that you can declare all kinds of crazy constants in your class if you happen to need that. Okay, now that we have this in place, we can head over to our main file and include our class. Let's do that. We're going to include cylinder.h, and we're going to go down and create a cylinder object and do things with it. For example, we can print the volume of our cylinder, and we can print the default color using the syntax here. This is going to work because default color is living in the public scope of our class. If it's not public, the syntax here is not going to work as we have seen before. But if it's not public, you can go through a member function to get it and print that out if you want. Down here, you see that we can even use an object and print the default color. The syntax here is also going to work without a problem. We can build this program. Let's use GCC to do that. And we're going to bring up a terminal to be able to play with us. We can clear and run Rooster. And we're going to see the volume printed out, and we're going to see the color for our cylinder printed out here. This is really all I had to share in this lecture, showing you that you can model constants in your class. Remember, before we had to maintain the pi variable in a separate file. It was on the outside, and that was really bad design because all we wanted was to use that to compute the volume of our cylinder. So in a way, the pi variable here is tied to the cylinder class, and now we have a design that really conforms to that because this variable is attached to the class and it's not attached to any object as we have here in the main function with cylinder1. It is attached to the class as a blueprint as a whole. It's not attached to any object here, and this is really cool. It is good design. Okay, this is working fine and we are happy. But what do you do if you don't have access to C++ 17 or a newer version? If that's the case, you're going to resort to declaring your variable in the class definition like this, and then you're going to have to initialize the variable in a CPP file somewhere. And we're going to see how you can do that in the next lecture. So go ahead and finish up here and meet me there.